Uh, Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you. And as you know, this course is multi-criteria decision making and under the NPTEL MOOC series, and this is a course which is spread over 12 weeks, which consists of 60 lectures, and we are in the 11th week of set of lectures. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you can recollect, as for the plan of the course, we had discussed a lot of examples first, then utility theory, then details about multi-criteria decision making, solved problems for linear programming, integer programming, quadratic programming. Then we very briefly considered multi-attribute, then went into multi-attribute utility concepts, just the formulas. Then we went into the different type of non-parametric methods. We have covered Electra method, epsilon Electra, Topsis, Vicor, and today we will start a new method which will be the coverage of this course. So, the broader set of topics is multi-criteria decision making. We have already covered multi-objective decision making. We have already covered multi-attribute decision making, the main points, multi-attribute utility theory, very briefly concept which I am again repeating. And the fifth set of type of methodologies which we will consider under the non-parametric method for multi-criteria is analytical hierarchy process. So, the word analytical hierarchy process is basically a subset of the ideas of analytical network process. So, we would not be considering the network process, we will only concentrate on the simple formulation of analytical hierarchy process. So, as the word hierarchy says, so there the decisions are basically broken up into hierarchies of decision, and then based on how the hierarchies are connected, we would basically go from the bottom level to the top level, keep adding the scores. How the scores are added, we will come to that later, and then rank the decisions accordingly. I will just keep it to the basics. Analytical hierarchy process is a structured technique for organizing and analyzing complex decisions. So, decisions can be to buy a car, decisions can be to buy an apartment, it can be related to choosing a program for higher studies, it can be all the different type of multi-criteria decision. These three examples I keep repeating in the way they make sense corresponding to the concept of the methodologies we are studying. It was developed by Thomas Saaty in the 1970s and is applicable for group decision making. So, where is analytical hierarchy process used? It is used in multi-criteria decision making. It is used in the case where both qualitative and quantitative decision makings are used. It tries to mimic human decision process, is actually generally well accepted in many of the decision making processes and is widely used, and it is easy to implement, easy to fathom, easy to understand and easy to convey the results to the other party, and it is quite intuitive. Now, I will try to draw the overall analytical hierarchy process and explain it in detail. So, what I will do is that I will create a blank slide and explain it in step by step. So, here how we will consider. So, this is the slide where we left. So, all the main points based on which why we are considering AHP as a method. So, how does the AHP schematically looks like? Consider the problem is, before I draw the diagram, consider the problem is to buy a car, and consider for our understanding there are 4 different cars to be analyzed. That means, 4 different alternatives from which we want to choose the car. So, without going to the name, let us mark it as like this. So, the alternatives for these cars is A1, A2, A3 and A4. So, these are the cars and I want to make the decision accordingly. Now, what are the criteria? So, the criteria I will mention, so that it will make much more sense why the criteria are be considered. So, I will mark the criteria with different colors, and as I do for each and every explanation in the slide as well as in lectures, I use different colors. So, that the information and the ideas which I am trying to convey is easily passed on to the participants and the students. And there is a very specific reason why I am trying to utilize different colors, which I will explain later on. Consider the first set of hierarchy. So, as I mentioned the word hierarchy, hierarchy means there are levels. Like if you consider a tree, and if you are taking the cross section of tree and considering the from the level where the tree trunk touches the soil and the root goes. So, if you consider that, it is like this. So, this is the level of the soil, this is the tree, and the tree trunk goes like this. So, even though it not exactly mimic the roots, but the hierarchies would be considered accordingly. So, this is what I will draw now. So, let me erase this one, because this was just drawn in order to make some pictorial imagination how the hierarchy would be there. Consider the hierarchies are, I will use the red color, the dark red was for the alternatives. Hierarchies are, say for example, price. So, I will mark it as C1. On the same level, the hierarchy next one, again it is red in color. So, consider the style of the car, the seating space, arrangement, the dashboard, how the car looks like. So, I will mark it as C2. The third one is again, I will continue using the same hierarchy color, consider it is mileage, C3. Consider the next one as safety, C4. Now, under C1, C2, C3, C4, which are the first hierarchy, let us consider there are second level of hierarchy. Some may have, some may not have. So, I will use now the green color. Price may have, say for example, purchasing price, which will be denoted because it is under C1. So, it will be denoted as C12, and there is resale price considered as RP. So, it will be denoted by C11. So, C11 and C12. Style considered does not have any categories, next hierarchy. So, let it be as it is C2. Mileage, say for example, I consider again green color. So, mileage I will consider as city, based on city, consider it as C31, and in the highway. So, better the mileage, better the car, I would consider this C32. Safety features, consider there are other levels of safety features, consider safety features can be crash safety features, and without naming it, let me put it at C4, that is C41, C42, and consider more such levels of hierarchies can be there, which I am not drawing. So, not to clutter the hierarchy as such. So, if I consider, so now I will only mark and use the nomenclature of the numbering. So, C1, C2, C3, C4, first hierarchy, C1 has C11 and C12, C2 does not have any second hierarchy, C3 has C31, C32, safety has C41, C42. And based on this criteria, what are you choosing? We are trying to find out which car to buy, and how many cars are there? There are 4 cars, A1, A2, A3, A4. And finally, what we want to choose is the main objective, the decision of buying the car. So, let me mark C1 to C4 are there. So, I will mark them as follows. I am not going to mark the price, style, mileage, safety. It will be only marked in the numbering scheme. So, the cars are marked as A1. So, now the hierarchy will be drawn considering this example, and the coloring scheme would be there in order to mark it. So, the main decision is to choose the car, which is decision of choosing. This is the black box. Black box not as is just the coloring scheme I am doing. So, this is the final decision which I will take, and in the next level there was C1 to C4. So, I will mark the connectivity with the black color, and this is C1, the first one, this is C2, this is C3. So, they are in the same horizontal level of hierarchy, C3, C4, done. Now, the next coloring was green. So, again I will use the black arrows connectivity, and they were, so there is no connectivity for C2 in the next level. So, I won't join it immediately. C3 had 2, C4 had 2. So, let me mark it as with the green color. So, this is C11, C12, C31, C32, this is C41, C42. So, the green color and the second hierarchy same horizontal level. Now, what are the alternatives A1 to A4? So, we will mark them. So, these are alternatives. So, A1, A2, and how the connection is done I will come to that. A3, A4. How the connections are done, I will use the black color arrow. That is why the coloring scheme I mentioned a little more details. So, my decision is to buy the car. So, it can be one of the scores is here. Now, A1 connectivity is there with C2 also. So, now as A1, for choosing A1 I can take the route A1 C11 C1 decision, A1 C12 C1 decision, A1 C2 the decision is the black final decision, A1 A31 A3 decision, A1 A32 A C3 C32 C3 decision, A1 C41 C4 decision, A1 C42 C4 decision. Similarly, for A2 all connections would be there, which is I will repeat for A2 C11 C1 decision, A2 C12 C1 decision, A2 C2 decision, A2 C31 C3 decision, A2 C32 C3 decision, A2 C41 C4 decision, A2 C42 C4 decision. Similarly, connection is there with A4 also. So, let us not get confused with this whole set of black lines, but I will again read it for A3 and A4 without drawing it. So, A3 C11 C1 decision, A3 C12 C1 decision, A3 C2 decision, A3 C31 C3 decision, A3 C3 2 C3 decision, A3 C4 1 C4 decision, A3 C4 2 C4 decision. Finally, for A4, A4 C11 C1 decision, A4 C12 C1 decision, A4 C2 decision, A4 C31 C3 decision, A4 C32 C3 decision, A4 C41 C4 decision, and finally, A4 C42 C4 decision. So, all the connection routes have been analyzed. So, what we will do is actually follow the paths from A1 to the decision with all the routes. Similarly, for A2, next is A3, finally is A4. So, there are 4 alternatives. We will find out the scores corresponding to A1 till the decision, then A2 till the decision, A3 till the decision, A4 till the decision, and rank them accordingly. So, when I tell or mention the word from the alternative, which is A1, A2, A3, A4 to the decision, I am trying to find out all the combinations of path for A1 and collectively finding out the combined score. Similarly, when I talk about A2 and the decision, I find out all the paths from A2 to the decision and combine all the scores accordingly. Similarly, from A3 to the decision and finally, from A4 to the decision. Now, the question which may crop up in the mind of the participant and the students is that, can there be more hierarchies? Yes, they can be. So, if you see this set of slide, the slide which is in front of you, there are technically 2 such hierarchy, one being C1, C2, C3, C4 at one hierarchy, and then C11, C12, C31, C32, C41, C42 in the next hierarchy. Correspondingly, the hierarchies would increase. So, the connection would be there, connection means the paths would be there, and you have to calculate it accordingly. The next question is that, can there be more alternatives? Yes, they can be. The final point is that, how do we give the scores in trying to find out the corrective scores for each and every alternatives. So, that would be analyzed in the process of the discussion AHP, and remember, the scores are given in such a way that we keep multiplying and then adding the scores in order to reach the final ranking system with respect to each and all alternatives and then rank them accordingly. So, this is the basic idea. So, in AHP, analytical hierarchy process, there are 2 fundamental approaches in solving the problem. One is the deductive approach and one is the inductive systems approach. Basically, the deductive approach focuses on the paths, whereas the system approach concentrates on the working of the whole, and one can basically find out more details about it in the book written by Thomas L. Satte, and the title of the book is Decision Making for Leaders. It is quite a comprehensive, nice book. AHP combines these 2 concepts which I just mentioned in one integrated logical framework. AHP is that it is designed to handle situations in which the subjective judgment of the individuals constitute an important part of the decision process, and this subjective decisions is basically analyzed giving scores. And if you remember, I have mentioned that we basically multiply and add these scores or points accordingly, and how these scores are given would be based on the analysis which the decision maker is making when he or she is trying to analyze the alternative based on the criteria. So, if you remember, in Electra process, epsilon Electra, Vicor, Topsys method, in all these methods we have considered the alternatives are being analyzed based on the relevance of the criteria, and this is exactly what we are doing. We will take the alternatives, try to compare the alternatives based on each and every criteria and then give scores. In the other 4 methods which I just mentioned, Electra method, Epsilon Electra, Topsys, Vicor, the concept of NIS, PIS, discordant set, concordant set, indifferent set, all these was considered based on the positive and the negative net worth. And in that those methods we have already considered the comparison was being done between two alternatives based on each and every criteria. We will follow exactly the same concept, but here some scores will be given based on the liking and the disliking, which we will see within few more minutes. So, how does the step for the AHP work? In exactly the same way, if you remember, in all these four methods, I will keep repeating them because there is a logical flow in the different type of non-parametric methods we have considered. So, there were steps given, and if you remember in the four methods we have already considered, Electra method, epsilon Electra, Topsis, Vicor, we considered that we had decision matrix based on the value, then found out the normalized decision multiplied by the weights, found out the weighted decision matrix, and based on the weighted decision matrix we proceeded to find out the ranking and give the scores accordingly. So, whether it was AIS, PIS, concordance, discordance, indifference concept, whatever. Here is we first develop the hierarchy of the components. Here means AHP. We establish priorities for the criteria, and priorities are based on the criteria when we are trying to compare the alternatives. We check the consistency, and consistency point is important because in many of the cases ranking system may not be consistent, and this point I have mentioned. In the sense, I will just briefly again revisit that point or that idea. Consider you have in the objective scale, if you had numbers 3, 3 is always greater than 2, and if 2 is greater than 1, then we can say according to the basic properties of mathematics 3 would be greater than 1. But if I consider these different MCDM techniques, then it may be possible that in one case A are the alternatives. See, for example, AI is better than AJ and AJ is better than AK, but it may be possible that AI is not better than AK. It is not obvious that AI is better than AK. So, those corresponding inconsistencies have to be looked into and taken care of. So, that is why the third step says check for inconsistency, establish the priorities for the decision alternatives based on each criteria as I just mentioned few minutes back, and compute the overall priority ranking of the alternatives. So, if you remember the graph or the hierarchy, and I mentioned about A1 till the decision, A2 till the decision. So, what we are doing when you are following any set of paths, and when I use the word set of paths, it means I am starting at A1 and reaching my decision. So, there can be different paths to reach that decision. So, I am basically calculating the points for each paths and keep adding them. So, that is what basically it says, compute the overall priority and then rank the alternatives accordingly. Decision analysis process involving finite number of alternatives arise frequently in practical situations. One must remember that the type of data available for analysis based on which one has to draw some conclusions can be deterministic, probabilistic or uncertain. When the data is uncertain, then one of the many tools which is very convincingly used, successfully used, is basically the analytical hierarchy process about which we are talking. In AHP, subjective judgment is quantified in a logical manner and then utilized to reach some meaningful conclusion. So, if you remember in all the four methods, again I am repeating, Electra, epsilon Electra, Topsis, Vicor, we had considered the normalization along the columns and all the criteria were mentioned along the columns. So, if it was a matrix decision matrix, which was the first one, non-normalized case, it was of the size m cross n, where m was the number of alternatives, n was the number of criteria. So, the normalization was done along the columns, and based on that we multiplied that normalized matrix with the weights. Weights were based on the criteria and found out the normalized weighted matrix. Now, the concept of trying to normalize it was very intuitive, because many of the criteria may have different units. Some may be objective, some may be subjective, and even if units are there for each of these criteria, they can be different, as I just mentioned. Like, one of the criteria can be based on weight, another criteria can be based on length, another can be based on amount of money, rupees, another can be based on volume. So, in order to compare these criteria where the units may be different, not commensurate. So, we normalize them and basically bring it on a score of 0 to 1. That concept will also be used in some way. Now, here when we give the scores based on the criteria for the alternatives, they are based on the ranking system of points, and then these points are utilized to find out the consistency concept and then do the ranking if the consistency is met. One must remember that the decision maker's assessment towards the risk and his or her attitude toward return or average benefit. So, the person is trying to balance the ideas of return and risk, and this point we have seen was very evident in the concept of epsilon Electra. Epsilon Electra had that idea that you were basically trying to divide the overall liking disliking for any criteria for the alternatives based on the concordance index, the discordant index, and the indifferent index was also brought into the picture, such that we had the concordance set, concordance matrix, discordant set, discordant matrix, indifference set, indifference matrix. This was not the case for the simple Electra. So, again coming back to AHP, this would also be considered accordingly, such that it would reflect, such that means when the decision maker considers the risk and return, he or she basically wants to convey the decision maker's overall outlook about any decision and take that decision accordingly. So, with this I will end this lecture and continue more discussion about the AHP in the later lecture. Thank you very much and have a nice day.